Welcome everyone. In this video lecture, we will solve a GATE 2015 question which is based on the output resistance calculation in a Mosfet. Okay, so the question is a Mosfet is in saturation region has a drain current of 1 milliampere for VDS zero point 0.5 volt and the channel length modulation coefficient is given 0.05 volt inverse. So we have to find the output resistance of a MOSFET. Okay. So this one is a very simple question, but we have to know the fundamental formula of the drain current when the channel length modulation is in picture. Okay. So first of all, I want to write the given thing given in the question. ID value in saturation region is given. Okay. So saturation current is 1 milliampere and this one for VDS zero point 0.5 volt. Okay, and the channel length modulation, that is our lambda, is 0.05 volt inverse. Okay, so the drain current when channel length modulation comes into picture, that is our lambda, channel length modulation coefficient, then the formula for this one will be id set 1 plus lambda VDS. This is a very important formula. Okay, or in general, this one is our mu n cox by 2 W by L 1 plus lambda VDS. Both are same. Okay, mu n by 2 cox W by L 1 plus lambda VDS. That is our same. The one ID set 1 plus lambda VDS. Okay. So now what we have to do, or in general, you can write this as a ID. This one is a ID. Okay. So we have to find the value of R out. Okay. So basically this R output is nothing but simply we can say del VDS by del ID. Okay. Del VDS by del ID is our R out. Okay. So in this case, what we have to do, this id equals to some function of VDS. So if we differentiate this del id with respect to del VDS, so this will give our R 1 by R output. Okay, 1 by R output, just a reciprocal of this one. So better to write 1 by R output. Okay, or it is our R output. Anything you can write. I am writing capital R. Okay, so it should be our ID set is already given, so I am writing ID set. Okay, 1, so it should be our constant term, so it should be 0. Okay, so we can say 0 plus then lambda VDS, so it should be simply our lambda, so the value will be lambda times of ID set, lambda times of ID set. Very simple. Okay, the differentiation of 1 with respect to VDS will be 0, so I am writing 0, and VDS it should be lambda, so lambda times of ID set. So the R output value, R output we can write as 1 by lambda times of ID set. It is very simple and very fundamental numerical is this one. So 1 by lambda is given, that is our 0.05 volt inverse. So I am writing volt inverse. Okay, into ID set into 1 by ID set. So ID set is nothing but simply our what, 1 milliampere. Okay, so one can write 1 milliampere. So 10 to the power minus 3 ampere. So better to write ampere, not issue. Okay, now one can write this as a 10 to the power 3 by 0.05. We can write as volt by ampere. So volt by ampere is nothing but simply our ohm. Okay, so one can also write this as a 10 to the power 3. If I am writing as 5 and just making 100. Okay, means if we remove this decimal, we have to multiply it with, okay, 10 square. Same thing I am doing. So it should be our 20, and this should be ohm. Okay, so 20 into 10 to the power 3 ohm will be our answer, or we can write this as a 20 kilo ohm. So the answer for this R output will be nothing but simply 20 kilo ohm. So this is the answer for this question, the output resistance. So R output 1 plus lambda VDS. One can remember, but no need to remember. But these are the fundamental formula that we have to take care. Okay, for the drain current equation. Okay, when the channel modulation comes into picture, we have to write IDZ 1 plus lambda VDS. Okay, clear? And this in this one also we have to write that thing. We have to write also, sorry, I have missed one point, means VGS minus VTN whole square. Okay, this one also we have to write this term. Okay, so this is all about this question. So thank you for watching this video, and it is a very fundamental question. So thank you.